SSD, SD, eMMC, RAW NAND. What are the differences? So the underlying technology with SSD, eMMC, SD, USB flash etc. Is NAND flash correct? So is the difference between all of them just the way controllers are implemented? Or are the technologies different altogether? From what I know, I think SSDs are for desktops and eMMCs are for mobile devices, but is there some intricate difference between all of these storage technologies?
NAND stands for negated AND. It often refers to the way the logic gate is built from silicon. Flash memory is also built from silicon chips and uses NAND gates. This leads to the term NAND flash. I suspect that this is the NAND you refer to, but for completeness sake I wanted to mention the background. You can build storage with NAND flash, but you will need some way to access it. For example, you can put a NAND flash chip on a PCB, add a controller chip and some USB logic and you get a USB pin drive. Or you can add an SD controller and put it in this format and you get an SD card. Both of these are relative simple devices, and when you store information on them you will write to a fixed location. This is a bad thing, because the number of writes to NAND flash is limited. You can add a controller to the device which makes sure that all writes are spread evenly across the NAND, while providing a consistent image to the computer. This requires a lot more intelligence on the device part and is done in SSDs. SSDs are supposed to replace mechanical hard disks and thus are expected to get a lot of writes. Is the difference between all of them just the way controllers are implemented? For SD/USB pen drive, mostly the same, just with a different interface. For SSDs, completely different controllers. Or are the technologies different altogether? There are several ways to implement NAND storage. The main implemented differences seem to come down to single cells, in which you can store a high voltage or a low one, SLC, or single level. Basically either on or off, or 1 or 0. Chips which allow multiple levels of power. Off, slightly charged, mostly charged, fully charged. Compare it to signaling with a stereo. SLC would be music on or music off. MLC would be off, soft music, loud music, and extra def mode. That leaves eMMC. I never heard of it before, but according to Wikipedia it is a flash memory card standard.
NAND, raw flash memory. Raw flash uses its own protocol, and this protocol includes reading pages, writing pages, and erasing blocks. It does not work like disks. Disks are able to read blocks and write blocks. Flash is able to read and write pages, and a set of pages called a block must be erased before you can write new data. You can only erase a limited number of times before the block wears out and won't fully erase anymore. SD, secure digital. It's a memory card format. SD cards contain a tiny microcontroller and NAND. The microcontroller implements a FTL, flash translation layer, that takes disk-like block accesses and translates it into meaningful NAND operations, as well as performing word leveling and block sparing. SD cards use the SPI protocol on the host side. USB SD card readers convert from USB mass storage commands to SPI SD commands. eMMC, Embedded eMMC, HE. This refers to basically what you can think of as an SD card that's built into a motherboard. SD and eMMC standards are very similar, enough that SD card readers can typically read eMMC cards, typically soldered in and non-removable. Typically it is connected to the rest of the hardware via an internal SPI bus. Cell phones and ARM hardware, and other embedded type devices, i.e. routers, may have this. Update, Some newer value-priced Windows netbooks are starting to have these too. SD cards and ink are slower than SSDs because the SPI bus is not as fast as the SATA bus. SSD, solid-state drive. A controller plus a bunch of NAND placed into a hard drive case. The controller implements a FTL, flash translation layer, that takes disk-like block accesses and translates it into meaningful NAND operations, as well as performing wear leveling and block sparing. Some controller types like SandForce, etc. are well known. SSDs use the SATA protocol and connector on the host side. If you are in a situation where you are dealing with raw NAND, such as the Guru plug, you are responsible for doing wear leveling and block sparing. Linux file systems like JFFS2 and such do this, but aren't needed where FTL does that work like on most SD cards, USB cards, etc.